Yeah, I can't play YouTube videos on YouTube. It keeps dumping the stream. Well, usually if you play other YouTube videos, they just demonetize you and give your revenue to the video you're watching. You do it with music too. So I think I'm back up and streaming. Someone want to check for me? Thank you, Dirty Dan. Fake streamer. Well, that was fun. Spargy, thank you. All right, I forgot what freaking shirt I was packing up.
Ticker FOUR, shares spiking with activity. Foxtrot Oscar Uniform Romeo.
X audio video available to any. Oh, that was rumored to happen. Did I miss Vanny? What's up with FOUR? Great call there, Looney. Look at that. Riley, jeez. Whoa, LUNR moving here. Oh, 2 p.m. Let's find the stream. Anybody got the stream? FI related acquire. Roger. Is it on their website? For FI. Thank you, Cheese. 2 p.m. is supposed to be their thing today, right? See if it's on YouTube. You got Revolutions?
Forward
Thank you.
to missions 2 and 3 and subsequent missions. We expect that the planned mission was going to extend on the surface for 144 hours. We expect that OD will sleep after that. We left every bit well, actually nothing left on the table. Every commodity, everything was used. All the helium was used. All the methane was used. All the power was used. And so we used up every bit of every ounce of consumables we took with us and generated on the way to complete this mission. So very excited about that. What we've done in the process of this mission, though, is we've fundamentally changed the economics of landing on the moon. And we've kicked open the door for a robust, thriving cislunar economy in the future. That's compelling. And so I think this CLIPS experiment, this first landing, this success on the moon, first time in 52 years, is really a point in history that we should celebrate. as we move forward to subsequent missions around the moon. We could not have done this alone. This was truly an integrated global effort, and I don't think everybody was aware of that. We returned to the moon as a commercial company, but we had multiple government agencies that we worked with. We worked with NASA, of course, and multiple departments within NASA. We worked with the FAA, the FCC. We worked with the Eastern Range, all of those to get off the ground. We then had a whole series of international partners that we used as not only our
President Biden said the results of
lunar
his
data
physical are no
network,
different from last
antenna
year.
dishes on the ground, but also in the supply chain. We had Australia, the United Kingdom, Japan, South Africa, the United States dishes, and KSAT dishes, KSAT based out of Norway,
Reuters reported
in India,
Pfizer,
Singapore, Dubai,
Amadeus
French Guiana,
V to acquire
and
shipment
Mauritius,
payments.
and
That's
India.
from
The supply
Reuters,
chain,
that's
I got to talk
Foxtrot,
about a
Oscar,
little bit
Uniform
from
Romeo, and
Canada,
Foxtrot, India.
MDA and Canadensis. Sweden, AAC Clyde Space provided that impeccable power system for us on the Odysseus lander. From Spain, where we got those Thales Alenia radios that gave us the ranging tones for orbit determination. And the United States, we leveraged countless companies and their strengths in our domestic supply chain. Everyone deserves a thank you for allowing us as Intuitive Machines to take the lead and lead.
Let's hear FOUR, Foxtrot, Oscar, Uniform
It's been a
Romeo.
daunting
That
journey.
circulations
we were met
of a
with over
takeover
11
chatter.
critical mission
Pfizer
challenges.
possibly interested in company.
And it was
Ticker
the only way to get
FI,
through that
ticker
was with
FOUR.
the people of Intuitive Machines who demonstrated resilience.
So if you were
and
along for a
perseverance
good
and
presser,
triumph.
FI dropping
this is not the
to
kind of
the
presser you
lows
want to
of
hear.
Bitcoin.
Challenges that were put forth.
Could
put
still go,
forward
but
in
this is
front
not
of
how
them,
you want to hear.
The whole way through the mission, all the way up until our projected end at this evening. You know, the challenges came from people ask, you know, why was
Projected
this so
end.
hard and why does it take so much effort if we've returned to the moon after 50 years? Why, and we did it 50 years ago, why is it so hard?
Funny, we just said that.
What we had was a different kind of challenge. We were constrained in cost with a fixed price performance contract from the government. We had a schedule where we were to get this mission completed within the time it takes to get an undergraduate degree. We had a technical challenge to land softly on the South Pole region of the moon. This over-constrained environment forced innovation, and this was our first flight of this vehicle, which had never been flown before in space, let alone been designed and developed. And this was a task that was given formally to nation states and sovereign governments, and we did it as a commercial company. We did this by building a robust lunar program that could launch and land more than one time. That is in place. The Intuitive Machines operations team has been practiced now like no other and can handle the challenges that are thrown for flying in space. We communicated in a way that not everybody was necessarily satisfied with. We learned in our communications. But what we tried to do was diagnose a problem and develop an approach and then communicate what our approach was going to be and how we were going to solve it that was going to improve or maintain Odie's health along the way. And I think we did that, and we did that effectively, and I'm proud of the communications team for what they have done. You know, data flows out of mission control in a very sporadic way, whether communications are happening.
Ticker
at the
MDRX,
pace
Michael
of near
Delta,
real
Romeo
time, or
X-ray,
they're
note
delayed
short
for the
report out
weekend
from
because
Bleecker
we're
Street on
struggling with
MDRX.
getting our telemetry down into these big dishes around the world. But every time we reported out the status of where we were. We've assembled the best and brightest in the company that I can imagine, and trying to create a business that's a national asset for the United States, and hopefully feed the lessons learned into IM2 and IM3 and our subsequent missions. I have a few very fascinating images for you that I can talk through now if you look up at the teleprompter. This is a picture of Odie on the surface of the moon, touching down with its engine firing. You see here the landing gear piece is broken off there on the left of the image. The landing gear did what it was supposed to do and protect the lander as it landed on the surface. The engine plume interaction with the surface gives us this excellent view of how the ejecta, the regolith, moves away from the plume interaction. There's scientific information in that data right there. What you don't see in this picture is that we landed, our navigation system landed us with precision and landed us softly on the moon. The
On
shock
its side.
absorbers took the load, and the lander now tilted over gently, and we think it's about 30 degrees, and communicating all the way down to Earth. And I think Tim is going to give you an estimate of how much data we've actually brought down. There's a little image in the center of the white patch on this. That's an American flag. I want to highlight that that American flag was a donation by NASA and is from 1970 in the Apollo program. And it was a certified piece of flight hardware.
LU1R
And we took
intuitive
that
machine says expects
American flag
Odysseus
and we
moon
proudly
lander
put it
to
on
go to sleep at
Odysseus.
end of the
carried it
mission
to the
today,
moon,
the sixth
like it should have been
day
done
of the mission.
52
That's
years ago.
LUNR.
So I'm really
sleep.
proud of
Navy
that.
uniform
Next
November
picture.
Romeo.
Go to sleep.
This picture shows the fisheye lens kind of view of, and all of the data that's within the how we're able to give you the images we have. All the data is there in this wide-angle view. Next image. And here we are, how Odie conducted the brilliant 6-day mission on the surface. You see the gold foil blanket is the helium tank. You see that we're tilted over slightly, still more upright than we initially thought. We did land upright, we captured data, and then we tilted over slowly in about 2 seconds and came to rest either on the opposite helium tank or a computer shelf, and we're able to communicate, get all 6 payloads data back, plus all the commercial payloads,
That's crazy.
and continue to
background.
transmit as we go forward. Brilliant performance by a small lunar lander and a brilliant commercial company called Intuitive Machines. Thank you, Nilofer.
Thank
Three
you,
cuts,
Steve.
a good start.
We'll now
Did he
hand
really
it
say
over
that?
To Joel. Joel, you're up.
Hey, thank you, Nilofer. So first, again, I want to again congratulate Intuitive Machines for this mission of many firsts. We mentioned many of them on Friday, but I want to talk again about the fact that this is the first time in the 21st century that an organization in the United States has landed equipment on the surface of the moon, and we're getting data back from that equipment, engineering and science data. It's an exciting time to be on day 6 of this new era in the 21st century. Now, a soft touchdown on the moon is a great accomplishment. This morning, in response to a question, our administrator of NASA, Senator Bill Nelson, in response to a question about does NASA consider this mission to be successful, said yes. This mission is a pathfinder. You can think of it as a flight test, a first step to get back to the moon, a pathfinder both for the more
but we don't need to
complicated
go
and
back to the moon,
sophisticated
the people
robotic
said.
science landing
There's nothing
missions
up
that will
there.
occur in the future.
There's no
And a
point going
pathfinder to
back.
get data for taking our human explorers back to the moon and to places on the moon that humans have never been before under Artemis. This also provides evidence for the first time that the commercial lunar payload services model, that is, that NASA could go out and purchase as a service, taking equipment to the surface of the moon and getting data back from the surface of the moon, can work. And it's the first time that we now have that evidence. It's also a soft landing at an extreme lower latitude on the moon, 80 degrees south near the South Pole region. And I want to point out why this is so different, because as others have said, we get questions periodically that since Americans did land on the moon in the 1960s, and we haven't been back in a long time until setting on this new road of getting science and technology on the moon, why is it really that difficult? And I want to remind folks that, and again, what you
We
have to
lost
do
the
to get down to
technology.
the surface of the moon, since there's no air on the moon, is in effect you have to ride a rocket all the way from the fast speed of being up in orbit all the way to practically no speed at a predetermined point on the surface at a predetermined elevation that you're trying to get to. And in effect, you have to bring down with you on the rocket all the fuel you need to slow down. So this is a very, very complex undertaking. And when we established the first set of CLPS landings, the first initial
That they-
ones
that they
internally
did
at
well in
NASA,
the
we
60s
discussed
and-
that the major goal was to soft land and get some amount of data back from our scientific and engineering investigations. And we can clearly see that we did get our cargo to the surface of the moon, and we have gotten data back, as project scientist Sue Lederer will talk about in a few minutes. There's also a lot of learning that comes out of this attempt. First flight of this new type of vehicle, Nova C, much of which
Getting real tight on this
Steve
lunar
Altman's
1 minute.
already touched on in his introduction, but also a lot of learning about orbit determination and use of commercial communication systems around the world. And I would like to point out that there were a number of organizations, as Steve said, that Intuitive Machines reached out to get either assistance or advice or information during the mission. We talked last Friday about Intuitive Machines' use of the onboard payload, the navigation Doppler LIDAR from NASA's Langley Research Center. But also there was close coordination and data from the payload Lunar Node 1 from NASA's Marshall Space Flight Center. There was a lot of support when requested from our Space Communications and Navigations program at NASA, in particular our Deep Space Network administered by the Jet Propulsion Laboratory in California. And also you will notice in the news that our Lunar Reconnaissance Orbiter, a NASA imaging spacecraft, did photograph the touchdown location of Odysseus on the lunar surface. And that required a lot of work by the Lunar Reconnaissance Orbiter project at Goddard Space Flight Center, the Lunar Reconnaissance Orbiter Camera Project, principal investigator located at Arizona State University, and others.
85
Many
and
of those
81.
elements together, although mostly you're hearing about CLIPS with this mission, LRO, the scientific instruments we provided, and CLIPS overall as part of NASA's Lunar Science
get you
Program,
10
or the
now.
Lunar Discovery and Exploration Program. Again, this was a Pathfinder mission. There's going to be a lot of learning that comes out of it when the mission is concluded, both for the company whose mission this is, Intuitive Machines, and also for NASA as we look back how we operated during this mission. And now we're looking forward to the future CLIPS landings coming up for Intuitive Machines. That'll be Intuitive Machines Mission 1. Will it take to the surface of the moon, again to the South Pole, NASA drilling and chemical composition determination equipment for our Space Technology Mission Directorate. And I'll turn it back to you, Nilofer.
Thank you so much, Joel. Next up, we have Tim. Over to you.
Thanks, Nilofer. Some appreciations that I would be remiss if I didn't offer up. First and foremost, as Steve said, our people, the amazing team of mechanics at Intuitive Machines. It is an excellent team, but it's also very efficient. We could not have done it without all of them. Every person was essential. And then behind them stands a network of family and friends who have sacrificed over the last couple of weeks to support us through some long hours and through some very exciting times on orbit. I would say NASA, not only for the moral and great technical support, Joel, that we've gotten in mission
Short chair
from
restricted?
DSN and from some of the payloads, but also for the vision going back
Wow.
from programs like
Didn't know
Morpheus and ALLHAT, which established the technology that was the foundation and the concepts that we wove into Odysseus as a lander. SpaceX was a great partner working a very complex problem
Break 80, and
of
it's on-
fueling a
5-minute
cryogenic
cup now.
payload at the Cape. Our
Diagonal is
commercial
down here
payload
at
customers
75.
for having faith in us. This is something that had not been done before. And they believed in us to see that we could pull this off.
Big bid down here.
And then
Where it
our
matters.
LTN partners, we had people on the phone listening
Tapped it.
with the most delicate instruments from Cornwall, from Kentucky, New South Wales,
VANI.
Okinawa, Bangalore, Karoo, Hardabeestock, among others, and really felt like
Shares,
we were
ticking a
part
bit
of a
higher,
global team
$4.71
as we found a way to
We're pulling
reestablish
back up about
science and data communications
367%
with
off
Odysseus
the
on the
earlier
surface of the
highs,
moon.
$7.80
There were a number of firsts on this
VANI.
mission. We're particularly proud of our cryogenic propulsion system. This was the first time, again, that a cryogenic payload has been fueled on the pad. The first time a flight of a composite overwrapped linerless cryogenic tank has been attempted and succeeded. The first time a Methalox engine has been fired in deep space, fired repeatedly in deep space. We enjoyed the fact that we set the record for length of an engine firing with our lunar orbit insertion, and then broke it the next day with our powered descent. So that was good company to be in, we thought. It's a deeply throttling engine. We used thermodynamic venting systems for cryogenic cooling, inline processing of optical imagery, which enabled us to land safely. And then we
Watch
collected
this
a ton of
75
multipath
break.
data from the lunar South Pole region. using our
75 and then
multiple antennas
72 and
radios.
then dumpy.
There are 4 things that we could not test before
Sounds
launch.
sexual.
We tested every system
All
in
right,
part
there you
and
go.
in whole where
Here's
we
a
could.
pop and
There were
drop.
4 things we could not test, and that this flight was going to validate for
Under
us.
675.
We could not test a
probably
fully loaded
catches some steam.
liquid oxygen, liquid methane vehicle through launch loads and vibes. No such facilities exist. You have to do the analysis, and you have to launch to see if your design
Did he
holds.
just say in
It does.
vibes?
WMT,
You cannot
Walmart,
test the free
computer glitch
flight
hold sales and
control
returns at
of a main
stores.
engine in 1G,
Walmart,
1 Earth gravity.
thousands of Walmart
You
stores
have to do that
nationwide
in
were
space.
temporarily
And
unable
we
to
did that with our
process many
commissioning maneuver and
transactions
our
Wednesday
trajectory
after a
correction
software
maneuver.
glitch emerged
We
in
could
the
not
systems
test
that
our
runs its
lunar
cash registers and
telecommunications
other
network
equipment.
with our radios
That's
at lunar
WMT,
distance.
that's
We simulated
on
it,
the Wall
we
Street
emulated
Journal.
it. We had to actually go into space to do the final test. And then we could not test our camera performance at the moon unless we were there. These were the 4 critical challenges as Chief Technology Officer that I knew we had to overcome and we had to demonstrate proficiency in. And I'm proud to report that we have checked all of these off, and we have a strong foundation for Intuitive Machines Mission 2, which will be coming up later this year. What does the future hold? Number 1, more cameras. The message is loud and clear. We need more cameras. We have that in the works, so more great imagery from the moon. IM2 and IM3, we have a commercial mission called IMC-1 in the works. We're working on a larger lander called Nova-D, and we're working on our own
Nova D's
communication
nuts.
satellites around the moon to enable business for ourselves and for other lunar explorers. I would like to talk a little bit about the ops dynamics,
I
just
had
to give you a
lock my
little bit of insight
C64
into the
stupid
room.
car.
It changed after we land. Prior to landing, we had 3 shifts and a team 4 who were very focused on the flight dynamics and control of a vehicle. Eyes were very much on the monitors and the consoles in front of you. Once we landed, we moved into how do we maximize the value of this asset for ourselves and for our customers. And the Ops Center became a swarm of activity. Just yesterday morning, we were in our high data pass over Parks in Australia. We had 3 mission directors in Nova Control.
650 test
One
again.
was focusing on pulling
Be
data
the
down
second
and
attempt.
managing the power and health
Don't really
systems
wanna
of
bounce here.
Odysseus.
It's
The
a big
other was
level.
working
650 is a
on
big level.
bringing the Scalps payload online so we could extract data from that payload. And Sue will talk more about that. And then the third, myself, we're working on getting the Eagle Cam up and ready for ejection. So it really was an all hands on deck. Let's maximize the time we have available on this asset while we can. And I think we've done an
650
incredibly
push.
effective job. And as of the
Again.
time I came into this briefing, we had brought down over 350 megabytes of science and engineering data on this mission. Nilofer?
Thank you, Tim, and thanks for sharing that wonderful data point. Sue, it's your turn. You're up.
I feel like I get the most exciting part of it, though I'm sure that
Maybe
IM
the-
won't
the
agree
ask
with me.
to stack at
I've been
651.
working
Oh,
with all
broke
of the
it.
NASA payloads for the last 3 years.
There we
I've had
go.
the absolute privilege to work with amazing groups of people
That
who
holds.
have really
Next
stepped
level
up to the
is
task
616.
as we've really encountered challenges in using these NASA payloads. But we've all worked together as a team. To my CLIPS
Feds Williams says
operating
3 interest
team,
rate cuts in
everybody
2024
really stepped
reasonable
up
for you
and
at
helped a
central
lot.
bank.
So teams, collaboration,
Officials to
people, this
debate
is really
says
stood
data
out,
driven
and so I
Lock it
wanted
in.
data will
make sure
drive the
that the
Fed
teams
cuts rates.
themselves all feel really good about everything.
Current
that
U.S.
they've done
economy
for
is
us.
similar to what it was
So
during
the
December
data
policy
that we've
meeting. Says
collected
it's
has come in
unclear
a number of phases.
what impact potential
During
U.S. government
transit,
shutdown
we
would
were
have
Watch
able
me
to
TV.
operate
Welcome on in.
all of our powered payloads on
from the
transit.
New York Fed
On
president.
descent and landing, our
Sales and
navigation
returns
Doppler
halted.
LiDAR
Was out.
NDL was
Was
able
at
to
Walmart?
collect data that will
Earlier.
help us to land safely in the future. And on the surface, the 3 payloads that were planned to operate on the surface have all been able to collect data.
What are we talking about here, Chief?
So I just want to take
Why
a
are they
little bit
halting
of time to go
returns?
through each of the payloads to try to really help you to understand what we've been working on. LN1 is a navigation and communication beacon that transmits radio signals back down to the Earth. They were able to complete 4 passes with Goldstone and Madrid, and 2 more passes to the Madrid ground station on the surface. So we mentioned earlier that LN1 has really stepped up to the task when
Walmart, computer glitch,
IM
all
came to us
sales
and said, hey,
returns.
we really could use
Interesting.
some help with navigation information. So I was in the car on the way home after pulling a triple shift. Sorry, Joel. And,
Cavity giving us the play-by-play
and calling
on
the
shorts.
LN1 PI, and I said, hey, Evan, is there a way that we can get your help with the navigation and working with the DSN? And he so calmly and coolly said, we're a navigation beacon. We're here to help you navigate. And that's what they did. So very proud of that team.
Reclaim is
ROLS's
650.
is the next one, and this is the radio wave observations at the lunar surface of the photoelectron density sheath. They have 4 antennas that were planned to be deployed on the surface. And Odie had a little surprise for us on the way with a little bit of help from the sun, creating a little bit more heat than we expected for the frangible. We did pop one of the antennas as we were in transit. And we took that as a sign that we were ready to start collecting science data. And why not take that opportunity? So while we had not planned to operate ROLS's at all in transit,
Bitcoin news circulating from CoinDesk. Morgan Stanley is doing due diligence towards adding Bitcoin ETFs to its brokerage platform.
So a little bit of bonus science. Thank you for that. So we're very happy about that.
A little late to the
remaining
party there, Morgan.
antennas were deployed on the surface, and we were also able to collect science data with those antennas deployed as was expected for that payload. Just a couple of notes from the ROLS's team that they have just started downloading this data in the last few days. And
I haven't pulled it up
already
recently,
they
but it
can
has
tell
been a
us
hot
that
play.
They have detected frequencies of radio noise from
Sorry,
the
I know
Earth.
there's a lot of new people on
But the
when I'm in
indication is that the
when I'm
lower
in a trade, I'm
frequency
not
data,
really looking at
Earth
chat.
is a lot more
So
quiet than they expected.
if you have a question for me
15
or comment,
megahertz, but at the
directed
higher
highlight
frequency,
message, and I'll
the Earth is definitely
see it hopefully
shouting
when I'm
a
out of the
bit.
trade.
So,
Usually I'm
and their
just
observations are also
juiced
consistent
looking
with the
out
radio quiet sun. So they're
where
already
I'm at.
collecting and really analyzing this data, and we have now downloaded additional data that we've collected just as we were getting ready for this brief. So we have all the ROLS's data down. SCALPS is the stereo cameras for lunar plume surface studies, and their goal was to detect the plumes being ejected and creating surface plumes or surface interaction plumes with the engine on the way down. We unfortunately had some hardware problems that did not allow the SCALPS instrument to operate during descent. However, one of the SCALPS team members, shout out to them, came up with an idea to potentially do some troubleshooting. And just 2 days ago, with very little sleep for all of us, the IM team was able to work with us very collaboratively in figuring out how to change how we were collecting data with the SCALPS instrument so that we were able to operate SCALPS from the surface of the moon just this morning. So a lot of people working a lot of hours, and a shout out to the SCALPS team for all their dedication in helping us and helping IM to figure out a way to get SCALPS to work. NDL is the Navigation Doppler LiDAR. It's for precise velocity and range
move up has
sensing.
been real
We've talked
volume.
about NDL and what they've been able
Moving
to
up,
do.
volume moving
They
down.
are
I know ticker
designed to
Coinbase
help
currently
safely
tweeting,
navigate
we
vehicles
appreciate your
to the
patience. We're beginning to
surface.
see improvement
All
in
of the
customer
NDL
trading.
data has now been received, and NDL reports that their instrument has worked far better than they expected, so we're very excited to see the final data outcomes from NDL. RFMG is a radio frequency mass gauge. They were able to collect data while we were tanking on the surface
right
here
has an
on the
oath.
Earth before we
What are you
launched,
talking about?
as well as loading those propellants on the launch pad, also during coast in the zero gravity of environment of space. that
CoinDesk
this allows
reported
us
that
to do. It's
Morgan
very hard to
Stanley
do
is
that if you don't have
evaluating
gravity pulling
spot
down your
Bitcoin
propellant,
ETFs for
as
its
well as during
brokerage
descent
platform,
to the
that's
surface of the
MS.
moon, as well as in lunar
All
orbit.
right,
So
there
we
may
collect
be
a
an
lot of
M
data
pattern
with
here
RFMG.
on
And
lunar with
this
the
is the first
resistance at
time
650
that
holding up.
RFMG has
You
been
break
integrated
this
into a
634
propulsion
again,
system.
I would expect to break it
Their
low.
results are really going to help us with guiding the future improvements of technology and integration for future Artemis missions, both to the moon and hopefully to Mars as well. And then finally, the LRA is the Laser Retroreflect Array. And we've been doing some talking back and forth over the last 6 days to figure out whether or not it was possible to range to the retroreflector. And hearing from the PI of LRA, we do believe that the NASA LRO
634.
is going to be able to use their LOLA laser altimeter to range to LRA. So we will be working on that in the coming months, and very excited to have a location marker on the moon at 80 degrees south, so that this is going to be great for navigation in the future. So I know that Joel said that we've had 6 days, and I would actually say that we've had 13 amazing days. So we are at lucky number 13.
Starting to stack.
In the first few days, we struggled to get communications, but the perseverance of the IM team, just not willing to give up, working with us, and as Steve noted, as soon as we landed and we started getting into what are we going to do and how do we do this? Their team pulled us, they came down to our NASA back room and said, we need to work this, come work with us, and pull us all into mission control. So we were collaboratively working together to find
do, Natty.
solutions so that the spacecraft could live, the payloads could get their
the
data.
Wednesday I tried to
And
say
instead of
they may try to
ending up
price
with a few
surgery.
bytes of
I
data,
did see
which
that.
was the baseline goal
Good
for
luck
us,
with that
we've
one,
got
bud.
over 50 megabytes of data, which we went from basically a
Good
cocktail
luck with
straw
that
of
one.
data coming back to a boba tea sized straw of data coming back. So we're all very excited now that we've gotten a lot of data back from the surface of the moon. So again, a shout out to the collaboration of the teamwork from the payloads, from the CLIPS operations team, from DSM, from IM. We've all worked together. It's the people that really make a difference and make sure that we go from how do we overcome challenges to how do we have this incredible
Sucks that it's short
success.
share restricted.
And that's where we're at today, is with
Based on
incredible
injury.
successes for all of our
There's
payloads.
our test of 34.
Back to you, Nilofer.
Thank you so much, and thank you for all of our briefers for their comments today.
85 break
What
should
we'll
get
do
us
right now
going.
is open it up for questions. So for those of you in the room, just raise your hand and we'll bring a mic over to you. And if you're on the phone bridge, please dial *1 to get your name in the queue to submit a question. Once your name is called, please submit.
There's your
Please
break.
state your name and your affiliation and to whom you'd like to direct your question. If you
30K,
find that your question's
test it
already been
again,
answered, please press
and
*2
we're
to
through.
withdraw it. Let's
In a
kick it
big
off
way.
with Gina Sinceri.
I'm
Now
gonna
we
start
got
with
what,
Steve.
27?
You said 11 points was kind of do or die. Could you tick-tock for me what those 11 points were?
TikTok?
Yeah, I'll defer that. I have that. I'll defer that to Tim, who's got the technical
Can you
background
TikTok?
to talk of those in a little more detail.
Yeah, there were a number of things we had to overcome, and some of
Is that
them
a
actually,
saying?
Gina, began before flight. So we had
27
warm
and broke.
methane on our first day of flight, and we had to work with SpaceX to adjust that and get ready to go for the second day. And so we
Down to
overcame that.
616.
I think we published the Star
After
Tracker
that-
issue, which was we had too tight of a tolerance check on a numerical condition for the measurements coming out of the Star
Next
Tracker.
level's
That
580.
prevented our vehicle from staging all the way to a sun pointing power positive. So we had to patch the interface with the Star Tracker to fix that. If we don't fix that,
I'm
the
gonna
mission
cover
ends
half
very
here at
quickly.
this level.
But the team was very effective on that. Another one that probably ticks off a few of those, we discovered in our commissioning maneuver that we had a drift in the yaw channel of our main engine control. So if you'll hand me micro OD. During a main engine burn, the way we steer the vehicles, we actually gimbal the motor. And so you turn it one way and it helps provide control in these two axes. We were drifting to one side during the commissioning maneuver, and then we saw it again in TCM-1. So what we had to do to troubleshoot that was to come up with scenarios where our engine geometry understanding and control would lead us into that drift. We knew we could do the small burns, but it was not going to be sufficient for the longer burns of LOI and power descent. So we did a couple of troubleshooting steps there. One was we moved the CG estimate on the
Dix
vehicle
is
around,
going up, huh?
which we suspected wasn't really the case, but it mimicked the signature we were seeing. And then we did a patch to our engine geometry, which was what we call an iLoad set, or parameters that the software reads kind of from a flat file. We updated our iLoads to redefine the engine geometry because we began to understand that under full thrust load, the geometry of our actuators was slightly different. And so we're able to patch that, and that led us to the successful LOI and the successful power descent. I will tell you that on the day of landing, when we watched the pointing control come across the consoles, it really looked like a video game. It was so good. I had never in any of our simulations seen the engine perform as well as it was after we had tuned it up through those burns. But if we hadn't done that, then we would not have been able to land on the moon. So those were some big steps for us. We published a few things about learning how to chill our engine in. We do have a cryogenic engine. We have to chill the metal of the engine itself before we can fire the engine. Our first commissioning maneuver, we didn't get it right on the methane side, and we had to try again, and we fired successfully, but not on time for the commissioning maneuver. We came back and reloaded for our first correction maneuver, TCM-1, and we missed the other side, the oxygen side. I may have them backwards. We missed oxygen on the first one, missed methane on the second one. And we had to reload, and a couple hours later we came back and we dialed that in. From that burn on, though, we had it perfected. And the next 5 burns, the process that we tuned once we were in orbit, we hit all 5 burns exactly on time of ignition. If I get to the moon and I miss LOI by even a minute, we don't land on the moon. It's very, very precise. So that was another one we overcame. We did end up in a lower orbit after LOI than we'd anticipated. Our paraloon was low. And fortunately, our flight dynamics engineers had preloaded the ability to do a lunar correction maneuver, and we were able to push that up and move our orbit from our planned lunar orbit, which would be 100-kilometer circular, basically into something very close to our descent orbit. So effectively, we had the agility in our control room to move deorbit insertion from orbit 12 to orbit 3, something like that. What else do I have on my list? Oh, we discovered that the laser rangefinders weren't working. Again, it was an interface issue, and we've talked a little bit about that. You know, there's a pin in the cable that's a safety
VLC
feature that once you put it on, you can't see if that pin's in place or not. And it's a Type 4 laser, so we didn't test it once we got to the Cape. Clearly something we can fix and rectify in testing on the next time through. And nonetheless, the vehicle performed just with our optical navigation system above expectations and allowed us to land safely. And then there were a number of other things that probably don't rise to the same level. And a lot of these things were crises anticipated, identified, and resolved before they impacted the mission. And so the team was excellent in saying, okay, if this is the challenge we're faced with, this is the resolution, and how do we marshal our resources in that control room and with our backup Team 4 to make sure they did not impact our ability to land safely.
Thank you so much. We have another question in the room that we're going to take.
Hi, Eric Berger with Ars Technica. First question is for Steve or Tim. Can you describe how the lander came to be gently landing on the moon? I guess it's only about 30% tipped over. Do you think it's leaning against a rock or something's holding it up? And then Joel, I'm interested in sort of your assessment of the mission in terms of the objectives NASA hoped to see from the soft landing to getting all the data back. Was this like 100% mission success from the CLPS program's perspective, or how would you sort of grade it?
So with respect to piecing together what happened at landing, we received telemetry. If you remember, on the evening of landing, we had no communication signal and then a weak signal. And in our consoles, the data was up to a point and then frozen until that communication was restored. So we had an indication that we had landed and we were upright with that stale data. And when we came back and looked at it, when we restored the communications, we noticed that we were getting the IMU telling us we see gravity more in the Z direction than in the X direction. Well, then we did a reconstruction where we actually calculated, based the trajectory, and the flight dynamics guys calculated that we actually came down just short of our landing site at a higher elevation than where our landing site was going to be. About a 1.5 kilometer difference between the ellipse of uncertainty for our landing and where we touched down. That elevation was higher, so we came in with more downward velocity, and we came with more horizontal velocity. And so we hit harder and sort of skidded along the way. And we see that disruption in the regolith from the LRO data that we've been able to get from LRO and ASU. And that discoloration says that we came down with the engine firing because the automated flight manager had not moded to where it was trying to sense and shut down the engine. We saw a spike when we touched down in the engine combustion chamber. That was like if you shut off the full thrust by landing on the surface. So we know the engine belt contacted the surface. The landing gear took the bulk of the load, and we broke 1 or 2 possibly landing gear. And so we sat there upright with the engine firing for a period of time. And then as it wound down, the vehicle just gently tipped over. And in our simulation with 1/6 gravity, we showed that it took about 2 seconds. And we landed on a 12-degree slope. And then that 12-degree slope, compounded with the helium tank underneath, or a radio shelf would put us at an angle that's approximately 30 degrees off the surface. And we have that photo now to confirm that's the orientation. We also know the roll orientation when we were going to set the high gain antenna towards Earth and the solar arrays for the sun. We know that roll worked, but we know when we landed, the top deck solar array was shadowed, and we weren't generating power with the top deck solar array, so we got that orientation right. So those were all the parameters that had to unfold over time to get us a good understanding of where we came. And then just today, we have this picture of us leaning gently on the surface.
If we can pull the picture up, oh, great, you read my mind. The LRO image, if you look at it, there's a large crater not far from where we landed. If you look in the middle of the picture, you see there's kind of a dark band. That is that crater. And so the beginning of that dark band is the shadow into that, what Mark Robinson from ASU tells me is probably a 2 billion-year-old crater. And the first edge of that darkness is about 500 meters from where we are. And then the ridge beyond that is another 500 meters, so about 1 kilometer away. And then you can see kind of a light band just underneath the helium tank, which is the lunar surface on the far side of that crater. So that'll give you an idea when you look at the picture of how we're oriented. In this picture, the sun is to the right and is moving across the sky right to left. And so it's illuminating the solar array on the other side. And you can kind of get a feel for that 30-degree, let me see if I can get this right. So the camera is kind of here, and it's taking a picture down between the legs. So we're about at 30 degrees on a 12-degree slope, landing like that. And that's how we get to 30 degrees. Earth is off in this direction, and so our antennas are in an off-nominal configuration. The reason some of this data took a while for us to get to is we had to really work with our in-network lunar telemetry partners, and then also with DSN to figure out what this strange environment was. Absolutely, our signals were bouncing off the moon. So we were receiving both the direct path signals from our radio and the opposite polarization as well. And so we had to sort through exactly how to do that. But once we got it down, we got into a rhythm where we could monitor health and send some basic commands for about 16 hours a day. And then we'd come over Australia, and we were able to really pull down data for about 8 hours at a time. And that was intense. That's where we had everybody in there. We had no dead air, just like in the radio business. There was no dead air, right? We wanted data coming down all the time. Well, I want to fix this payload. I want to work with scouts. Great. Be downloading data while you're working with scouts. And so that was kind of the operation we had. I know that wasn't your question, but I just wanted to talk about it. So, sorry.
I can answer your question you had about how we feel about mission success. We don't have a quantitative number to give. As I said earlier, from Eclipse point of view of demonstrating the model, our goal for the first set of task orders called Task Order 2,
Patience, let's go,
the big goal was
bud.
to land your equipment softly so you could get data from it after you land, and that was done successfully. We also identified objectives that we had for each of the science instruments, and we're assessing based on the data
36
to date
months.
and how that was influenced by the landing attitude, how we did. For example, Susan Lederer mentioned that we plan to take images from scalps on the way down to look at the interaction of the rocket plume with the surface. We know that we didn't do that. But we're fortunate that
Get
several of
wrecked
these
for saying
instruments,
shit and therefore
like
your
Scalps
Texas
and
speech didn't
Rolls-Royces,
work.
will fly
Come
in
on,
future
Googly, you
Eclipse
know
programs
better.
Also. So we have an opportunity in the future to take
How
that
was
data on
Cabo?
different
I've never been.
Great. We
I
will
want
now
pictures,
transition
Googly.
over to our phone bridge to take additional questions we have, and we'll kick it off with Marcia Dunn with Associated Press. Marcia?
Oh, hi.
Marsha,
Hello.
Marsha.
For Steve, please. How much time does Odysseus have left? How many more hours do you anticipate? How will you know for sure that it's the end? And
This
are
person
any
sounds like a bag holder.
planned for when the lander falls silent? Thanks.
Well, I think what we're going to do is kind of tuck Odie in for the cold night of the moon and see if we can't wake him up here when we get the solar noon here in about 3 weeks. So we know through that we are degrading in power, and we expect that within about 5 hours or so from now is when we will be at a point where we will no longer have commanding or telemetry coming down. We are going to leave the computers and the power system in a place where we can wake it up and do this development test objective to actually try to ping it with an antenna and see if we can't wake it up once it gets power again. So that's the plan. And if you recall, the whole idea of this mission was not to live as long as you could on the surface. This mission was intended as a scout and a pilot mission to go land on the surface, collect the data, and then the cold of night was going to take the lander and where it would sit there quietly for the rest of the time. We accomplished that. And so now extending to get additional data beyond that planned mission end and quiet power down of Odysseus, we expect that there may be another opportunity here in a couple of weeks to take a look at it again. So no eulogies planned, Marcia. Only celebration and cheering.
Thank you so much for that. Next up, we have Joey Roulette from Reuters. Joey? All right, we do not have Joey Roulette. We have Andrea.
These guys are more excited about landing a robot on the moon, half tilt, crash, whatever, than Buzz Aldrin and all the other dudes that actually walked on it first time. All right? Okay?
Mission goals, right? And what is that?
Just saying.
What do you guys want to see? And then I guess for Steve, how do you
50 years later
companies are aware of the problems that you guys faced? Are you looking to share the lessons learned from this mission with Astrobotic and Firefly, maybe? Thanks.
Well, I can address the surviving the night. You know, the real limiter, the number one limiter we face is the batteries. Batteries are a chemical asset. That chemistry does not respond well.
5-minute cut here.
And so if something happens to the batteries for 14 days of less than 250 degrees, then we won't be able to come back up. And the batteries absolutely are not tested to that level of cold.
Intuitive Machines CEO said expects 5 more hours before Odysseus lander goes to sleep.
To tell us what the probability was of surviving the deep cold,
degrading in power.
They would not put it in writing, and so they shouldn't.
That's LUNR.
So those are the things we're worried about. Our solar arrays should handle that fine. So we're confident that when the sun comes back up over Odysseus, that the solar arrays will energize and they'll send power. The real question is, are the batteries there to receive that power and pass it on? And then will the electronics within our computer and radio have withstood that deep cold and not basically cracked under the thermal stress?
How does that not get tested?
Wouldn't put odds on it, but those are the things
How
we're
do you
facing
not test for that?
When the sun comes back up on the solar
Unless
array
you
in a
just
few
didn't
weeks.
care.
Yeah, and for my comment there is we're in a position where why not try? You know, with no odds on it. Let's see what happens.
I guess they just didn't
gain
care. It
some
wasn't
data
part of the
and
mission.
insight that we otherwise wouldn't get if we weren't on the surface of the moon.
We've also overcome challenge after challenge after challenge we didn't know that we would be able to get past. And he's a scrappy little dude.
Yeah, I would not bet against
I have confidence
Odie.
in Odie at this point.
That's right.
It's been incredible.
As far as sharing the data with other industry vendors who are attempting to land softly on the moon, also, we certainly want to
someone
give
could
them
look up
the insights
the rating of those
our
batteries.
learning and our experience. And I think there's a whole series of conference papers and talks and briefings on what we experienced and what we learned that are part of this historic journey that we want to share. We want to share and talk about and let people know so that we raise all boats and we all end up building this
Ticker AQST Alpha Quebec, Sandy Tango, no sure seeing a spike in activity, new highs. Note this is a microcap AQST.
Andrea?
Hi, thanks for taking the questions. This is for Steve or Tim. Can you share a list of mission objectives and which of these were met and which were not? Also, can you explain a little more why you could pull more data when over Australia and not at other times? And then for Sue, so all 6 NASA payloads received data, but what was the quality of this data? Was it the quality expected or was it limited by the lander tipping over? Thank you.
Well, I think we had some very high-level mission objectives was to touch down softly on the surface of the moon softly and
There's
safely.
nothing. There's not.
And
I don't know.
return
I
scientific
mean,
data,
if I was a baller, I'd hold
to
this
our
overnight
customers.
because there's just nothing
The two
else.
primary
There's nothing
objectives.
else.
And both
This
of those
thing's
objectives
dying.
are
It's
met.
gonna
So
dead.
in our
Could be
mind,
dead.
This is an unqualified success.
There's nothing else.
I think
What are you going to go
internally,
long on?
We had objectives to really wring out the performance of this vehicle and understand that the
The only
engineering
thing that can
process
move it
we
is
went
just traders
through
playing it.
from design to development to testing and assembly, integration, and integrated testing was that model in the way we did our aerospace engineering was that solid thesis and a solid model. And in fact, it was, because this spacecraft is such an amazing spacecraft that we did fixed price in a short amount of time that was able to perform everything we asked of it. So I think those are my top 3 mission objectives. Tim, any insight on
This
others?
is the
with
Intuit
respect
Machines
to
LUNR's
Australia,
presser about
we do have our network of
whatever.
dishes that range
Their
anywhere
lunar
from
lander.
18 meters to 32 meters, except for the dish in Parks
go along
Australia,
with
which
it.
is part of CSIRO, and that's the dish. They made a
flop
movie
on the
about it called
ground,
The Dish.
then
It's a 64-meter dish. Now, it can only receive, but it has a
fake.
very sensitive ability to detect radio signals. And we were transmitting not through our high gain antenna, we were transmitting through a Omni antenna about the size of this water bottle. And that's what we had to transmit. And oh, by the way, it's not pointing at Earth. And so the way our engineers were able to work with the engineers at Parks to pull that data down was fantastic, but we could only do it when we were within the physical limitations of the Parks dish to go horizon to horizon. Oh, by the way, when you move a 64-meter dish, if the wind kicks up above a certain level, it stops. And so we all of a sudden became hedge meteorologists trying to predict what the winds would be like during our data passes. But I really have to give it to the team in Australia. They did a fantastic job allowing us to get this critical data down.
You also posed a question about what was the quality of the NASA instrument data that came back. I'll turn that over to Susan Lederer to address, but I'll point out that part of the goals for each instrument on this initial mission were to make sure that the instrument functioned, that it was fed power, could pass commands into the instrument data back to the ground. You could think of that as kind of operational demonstrations. Then there would be engineering data that the instrument would take, and then finally there would be the measurements that would be taken that you could think of as being the science that comes out of the instrument. So Susan, could you say a few words about the quality of the data that you've seen?
Yeah, absolutely. And it, of course, depends on which payload you are working with. Some have gotten more data, some have gotten all the data that they were hoping for. Bottom line is that every payload has met some level of their objectives, and we're very excited about that. Joel mentioned that we have tech demo instruments that are on board. They have now graduated to have actually been navigation instruments that I worked with IM, helping them to land safely on the surface, both LN1 in transit as well as NDL on descent. So we're very proud of our payloads. We're very excited to start pouring through the data. And in fact, on my way here, I was listening on the loops as data was being downloaded just hours before, and in fact, just before we walked into the press briefing, indicating that all the data that we've taken is now on the surface. So our payloads are very excited about being able to now analyze this data. So I want to give them all a chance to rest first, and then we'll get into at what level have we succeeded. But everyone has succeeded at least at, in some of the objectives.
So I have a question for Sue and Joel. If Odie wakes up in 2 or 3 weeks, do you want to turn your sensors back on?
Absolutely. The scientists always want more data. Always more data.
We'll give it a try.
As do the engineers. Great.
Great. Thank you guys so much for that. Next up, we have Chris Davenport with the Washington Post. Chris?
Hey, all. I guess for Steve and Tim, I was just curious if you could talk a little bit about that safety switch, which you, I think, said was sort of like the safety of a gun, and it wasn't switched to enable. Just curious what happened there, how something so important could have been overlooked. And then for Sue, a quick follow-up on what you were just saying. On the Scouts instrument specifically, if it was not working during the descent, if it only started working 2 days ago, were you actually able to characterize the dust plume that was kicked up by the engine if it wasn't working then? I'm just sort of curious if you are able to get a sense of how an engine will interact with the lunar surface and disturb it, if you'll actually be able to sort of perform that analysis. Thank you.
Chris, for your first question,
This is
we have a
a
difference
pretty shitty
between,
5-minute cock going on here.
the engineering development units that we use on the ground for the laser rangefinders and the flight units that were on the vehicle. When we tested the laser rangefinders on the ground, the engineering units did not have that safety enable switch, if you will. When we tested the flight lasers on the ground, we had ground support equipment feeding the power to those units. In those cables, there is a wire that pins into a connector that provides power to disable that safety enable and allow you to fire that laser rangefinder, and we did that, and it worked. The flight cables, however, did not have that wire lead in them. And so, there's a range safety requirement that you do not have an active laser with a potential to fire it, and you needed a limiter while you're on the launch pad getting ready to launch. And so that's why that safety enable is in that box, one for ground safety, one for range safety limits. And so there is a difference between how we test on the ground and the units we tested and the cables we used versus the cables we built for flight. And that one wire in miles and miles and miles of wiring on the vehicle and different harnesses was an oversight. And we missed it, and we're not able to command that disable switch on, and therefore didn't have the laser rangefinders. And so a couple of people beating themselves up pretty bad, but the fact that we were able to land softly using optical measurements is just a breakthrough in the performance of this vehicle. So, hey, if we missed a pin out of 3 miles of wiring and 10,000 pins and connections in the connectors, I'll take that all day long.
To answer your question about scalps,
Boeing
you
had
are correct
something about
that
missing
because
pins
we
too.
were unable to collect data on the way down. We know that there was a hardware failure that we fixed in the serial.
How many millions of
port
dollars
after
this
we were
thing
on the
cost?
surface. We also didn't trigger in order to.
We missed a
that
wire.
had been working.
We missed a
didn't have the
pin. No big
triggers that were
deal.
available that
Jeez.
were necessary to collect
Who cares,
that data on the way down,
really?
is my understanding. And so we were not able to collect the data for the plume surface images.
Maybe the people that paid
Scouts
for
was
it.
to take. However, a couple of
$118
upsides
million?
is that not only
Jeez.
were they able to meet some of their minimum success
pay
criteria,
for perfection
surviving
when you start
launch,
crossing
completing
into those
transit
kind of
checkouts.
numbers.
They were able to do a transit checkout on the surface. And this is important for them because there is another mission, as Joel mentioned, the Firefly mission that's coming up later this year has another version of Scalps, so they will be able to
Well, good to know
use
that
data to
next
better
launch,
plan
whenever we
for
get a
what to
date
do
on it,
for Firefly.
is a playable event
And then in addition,
with this
there were
thing.
certainly images that were taken by the other cameras that were on board.
Like,
and
probably
just
go
before
pretty
this
heavy on it.
press conference started, we did hear from Intuitive Machines
Dak
that they
Trump,
are
when it's
absolutely
hot, you
happy
keep
to
going.
share those images that they
You keep
collected
going,
with their
homie.
cameras. We have seen some of them, and we see some of the plume coming up from the surface. And they are willing to and very happy to collaborate with Scalps to share those images so that Scalps can use that data to do some analysis of the plume surface interaction between the engine and the dust on the lunar surface.
Lots of real-time updates we have today. Next up, we have
I
Micah
haven't seen very many trades
Maidenberg
I've
with
cared
the Wall
about,
Street
honestly,
Journal.
besides this one.
Hey, good afternoon.
See you, Guac. See you tomorrow.
First for Tim, how many of the 11 kind of critical moments that have been discussed, could have caused a mission failure? Is that all of them? I think you said some were a little bit more serious.
You got a trash bag full of Legos for $5?
And then Steve,
Like completely full?
given
Shut your
IM-1,
freaking face, Soils.
If the mission has generated new deals or interest from commercial customers or non-NASA customers for future landings.
8 p.m.
Or
Join
if
us.
not,
Do it.
how
What are you talking about?
You're thinking about pursuing those.
Like
given the mission
full
so
trash
far.
bag,
Thanks
like
a lot.
60-gallon trash bag, or what are we talking here?
Great question, Micah.
I don't care
one
what
thing I'll say about some
original
of these
or not.
critical events that we saw.
Dune
going
2s
through the
today?
mission, they didn't all have the
I
same
will be
time
watching it,
content.
but not today.
So, patching the Star Tracker was something that had a
I got hockey
definite
today.
immediacy to it, because if we don't get that fixed, then we're going to run out of power in a matter of hours.
35 gallons for
The
$6.
challenge of
You just
making
hit the
sure that
jackpot,
we had our
You just hit an
engine
absolute
start
jackpot.
sequence
300 to
was one that we had
500 bucks
opportunities
easy.
built into the mission
Right
to
till
resolve
8?
that as we went. So
Golly, no.
if it had gone
hockey.
uncorrected over the course of the next 4 burns, then mission success was not assured. But we had opportunities built in to resolve it as we went. So the
That's a
time
fine.
constant
That's
on
a
that
score,
was a little
dude.
bit different. The same thing for fine-tuning the engine geometry and making sure we had the steering coordinates.
You'll never
updated
get deep
for
cheese
what we
on
were
the
actually
stream.
seeing in flight.
Can't even
So
get him
it
on
was kind of a
microphone.
mix.
You can't even get his
any of these
face. You
issues
think
are
you're
left
going to get him on
unresolved,
stream?
they become
Good luck
major.
with that.
But not all of them were critical in the sense of, I need to solve them in the next couple of hours, or we're in real trouble. With that said,
There's a bunch of you I'm trying to
this
get
is a
on
sprint
microphone.
mission
We
to the
finally
moon.
got Nick
We
for
did the
a
fastest
few days.
transfer
Buzz,
from launch to low Earth orbit that
QFI.
anyone
We're
has
never
done
going to get
since
Titan besides
1972.
like
And
a
you
what's up
definitely felt
once a
that
quarter.
pressure of, I only have so many days, and the clock is ticking to get myself into lunar orbit. So I wouldn't
edited
necessarily
pants.
say that we breathed easier on the
Yeah,
ones
she
that we
sent
knew we
me
had a
a
little
bunch
bit
of
more
feet
time for
pics the
because
other
they were
day.
critical. But I do want
Literally
to emphasize
feet
that the time
pics
constants
of
in
his
these
feet
were
and
were
probably
very-
other people's feet.
Yeah, the one thing I'll add to Tim's question, or the question he just answered, is that about 3 days into the mission after launch, we said to ourselves, we got the mission directors together and the Team 4 leaders together and said, look, we've got to get on top of this. There are things that are happening to us, and we're in reactionary mode.
QFI is running
make
like a
sure we
90%
save the
win
vehicle.
rate over
We've
the
got to be
past
looking ahead
year now,
and anticipating
and he's still
what
hesitant
might
to get
happen
on mic.
downstream. So as we
He doesn't want to lead anyone astray.
We got
I'm like,
further and further
you have a
ahead, thinking about the
90% win
possible
rate,
failures and what could
QFI.
get us, and what we had to fix in that certain time frame. And once we did that, I think we really had ourselves in the right mind frame to succeed.
See, that's what I'm saying, Buzz.
And
No,
on your other
no.
question, Micah, is that
I open my
we
dumb
have
mouth
been
every single
contacted.
day,
I think,
and
the
I can
ESA,
think of 10 people in
contacts
chat
that
right
we
now
have
that are
and
better traders than
representatives
me.
we have, we're very excited.
Probably
for our
20
mission.
people.
And they. We've
You don't
been
have to
talking
be
a
the
number
best
of
to talk
European
about what you know.
companies that are flying equipment on
See,
our
that's what I'm
mission
talking
too,
about.
And ESA expressed interest in wanting to participate with us in flying payloads.
QFI won't get on because he doesn't
We've
want to
heard
lead
from
anyone
several
astray, his
companies
last
who
words.
wish to
So like, give me more time. Give me more time. I'm like,
sponsorships.
you have a
So
90% win rate on the shittiest year ever.
Conversations yet, other than their outreach to us. And so I just think it's the tip of the
Easy
iceberg, and it's
trade.
beginning
Shut
for
your-
people to realize, wow, this was an incredible success. What are the possibilities? And I think that was the whole purpose here, was to open up space exploration to be everyone's. And so more and more people can participate. And if that's the result we get, I'm happy for that.
Great. We have quite a few questions we want to get through this afternoon. So next up, we have Jeff Faust with Space News. Jeff?
Good afternoon. A question for Tim or Steve. If you had a working laser rangefinder, how would the final phases of landing potentially played out differently? Would you have been able to recognize you were approaching an area of a higher elevation and adjusted the landing appropriately so that you would touch down more softly, or would the slope of the landing area have made it difficult to land anyway? And then also, we heard on Friday about the Herculean efforts you made to incorporate the NDL data into your software. Did that not help on the final phases of the landing? How did that play out? Thanks.
Yeah, great questions, Jeff, and I'll try to be brief because Nilifer's asking me to. If we would have had the laser rangefinders, we would have nailed the landing. We actually have a terrain map built in to the system that anticipates the terrain we're going to fly over. It is robust to variations in that terrain. We've tested it for robustness to make sure that if we're off a little bit, it doesn't throw us off, and then it converges at the landing site. I'm confident if our laser rangefinders had been integrated in the system, we would have absolutely hit the bullseye. With respect to the NDL, what we had done, we absolutely succeeded in wiring the measurements in to the laser rangefinder registers. We absolutely succeeded in remapping the geometry of the laser rangefinder laser beams to what the NDL laser beams were. And we did all of that in the navigation algorithm. The part we missed was there is a data valid flag that's set all the way back in the laser rangefinder itself. And we needed to populate that in the navigation software that we patched to basically hard code it to 1. And because we missed that, the navigation algorithm said, you've got measurements, but I don't see my data valid flag that I'm expecting from the original laser rangefinder. So those did not process after all. So basically, we landed with our IMU and our optical navigation data flow algorithms, which were unique. It's the first time anybody's flown this algorithm, and it exceeded expectations because we lived to tell about it.
Thank you for that, and thank you for your brevity. Next up, we have Adam Mann with Science News. Adam?
Hi there. I guess this is a question for Steve or Tim. Would you say that the lander has performed about what you expected, or has it kind of like exceeded what you would have hoped by this point?
Well, I think we'll both answer with as brief as we can, Tim. So
Quite another real
this
gurus.
lander
100%
has exceeded
Buzz.
all my
That doesn't mean you
expectations of how
can't
it was
give us a
going
little
to,
taste. Give us a little
how it's
taste,
going to
Buzz.
perform.
You're not selling anything.
When we look at the systems today, nothing broke. The landing gear was subject to an environment that it was not designed for, a harsher landing that was outside its design limits. Everything on the spacecraft worked. We had single string items, we had redundancy, dissimilar redundancy, we had all kinds of protections that we could put in place within the limits of our schedule and budget. But man, this was a very robust lander I'm very proud of. And you know, the little bit of a wire issue here or a little enable switch over there, those minor things are easily corrected. But when I think of major redesigns, we're thinking about adding cameras and adding antennas, you know, things like that. But really a robust, I think somebody called it a beastly lander.
Yeah.
Scrappy little guy.
Scrappy little guy. Absolutely, Odie exceeded expectations in every effort, every area. And one thing I would add to that is our operations team and what they had preloaded in for how to use this machine on its way to the moon and how to command it and to respond to different conditions was masterful. And the vehicle responded to all of those commands. It responded to every demand we put on it well above expectations. And so it set the bar high for IM-2.
Thank you so much for that. Next up, we have Leonard David with Scientific American magazine. Leonard?
Yeah, thank you. Maybe for Steve, I love the term overconstrained led to innovation. Maybe you could break that out a little bit. And I'm curious about IM-2 as far as the launch date, what you see, and how would you gauge that particular landing area, Shackleton Ridge, compared to this? How would you gauge the difficulty for IM-2?
Okay, so on the first part is, you know, there's a lot of organizations that have an innovation officer or have innovation initiatives, and I'm not quite the believer in that. What I see firsthand from this effort of trying to go to the moon and return the United States to the moon for the first time in 50 years is that the innovation came from being absolutely overconstrained, where you didn't have enough time, you didn't have enough money, and you were trying to tackle a problem that seemed almost intractable. And so, with that said, we put a culture in the company of Intuitive Machines that there is no giving up, there's only perseverance, and there's only losing if you give up. And so find a way around it. If you can't test it one way, you have to test it another way. You can't have an unlimited budget. And knowing those constraints, you have to run lean and with agility, and innovative ideas come out in the form of all kinds of inventions and techniques, just like how we produced this one-of-a-kind, brilliant LOX methane injector for our main engine. We were able to get to a process where we produced a power head for the engine and injector every 10 days and then test it on the stand. We 3D print it in 5 days, post-process it in the machine shop, get it on the mobile test stand and fire it and characterize it in 10-day increments. We were able to build 40 injectors in the period of time that we needed to build that engine and make it fly. And you know what? It flew perfectly. So that's an example, and I think there's a whole case study to be done on how we've done this lean, agile development that could be quite disruptive to aerospace in the way we've set the bar for a new price point for going to the moon and opening up the cislunar economy. The other one for Mission 2, I have so much more confidence knowing that the flight control, the propulsion system, and in fact, these algorithms, navigation algorithms that Tim talked to, can put us down in an area of craters and shadows, and they can put us down with precision. And that precision is what's needed if we're ever going to get to the South Pole. The fact that we had this trial run to the South Pole region, and we did it without a laser altimeter, only gives me confidence that when we put those laser altimeters in, we're going to stick that landing.
Thank you so much. Christine Fisher with CNN. Christine?
Thanks, guys, and congratulations, everyone. Steve, 2 questions for you. First, can we get a quick update on Eagle Cam? And number 2, when I interviewed
No, it's in Apple News. Apple now
with China
releasing updates to its EU store updates, as Apple will now be offering alternative payment options. The EU will now be accepted in the App Store Connect. European-related issues on that news. Sticker Match Group seeing an increase of activity.
Number 1, with respect to Eagle Cam, what an amazing team of faculty and students at Embry-Riddle Aeronautical University who put their heart and soul into an ejectable camera that would come off of our Nova C or Odysseus lander and eject to the surface. Unfortunately, we couldn't get to that with the power descent the way it happened. And so this morning, I think it was this morning, as we went to each payload to try to reactivate them, we were able to reactivate the Eagle Cam. We reset the vision processor unit, powered up the Eagle Cam, and were able to eject it. And it ejected about 4 meters away from the vehicle safely. However, either in the camera or in the Wi-Fi signal back to the lander, something might not be working correctly. And so the Embry-Riddle team is working on that and wrestling with that to see if there's anything they can do. I think it's a wild success. I would love to fly the Eagle Cam again. Those students put their heart into it, and it's a really innovative design. And if we can get a picture of a landing, I'd love to give it to them. So we'll see what happens going forward with that. With respect to competition and the geopolitical environment, it's good to be first, and it's good to be on the surface in the South Pole region. And I think what it is all competition is not bad. Competition, in fact, when you can go put your resources to bear and you can go try and step in the arena and try to succeed at something that's very difficult, and then come out of that feeling of triumph and achievement of success, that's winning.
I gotta go to the post office, drop all this crap off.
Thank you for that. Rich Trubeau with the Orlando Sentinel. Rich?
Good day. Needed one of these.
Actually,
another 2K day on the year.
About Eagle Cam as well, but just
almost touched 40K once again.
Yep.
I'm gonna raid PCG. Say hey to her.
On IM2 or IM3, and
remember, space is fake. Yep.
Well, I'm not
we
sure
didn't land
exactly
on the moon.
when.
Aliens are real.
I'm not sure whether or not the university can do it.
All that good
nice.
stuff.
We'll
Thanks for all the new follows today. Runks, Dumpsty, Stock Screener, Watch Mex TV, Killer,
a pep talk that they built a piece of G9,
Super,
to the moon and ejected the camera.
PewDiePie on bridge. Jeez.
Now, can we get an image? Let's work on that. And so we'll see how that plan shapes up over the next coming months and see where that Eagle Cam might lie in the future.
Be back out tomorrow. Got back to green on the week.
Next
That's good.
Up, we have Irene Klotz with Aviation Week. Irene?
You guys have an awesome time watching this stuff.
Steve or Tim,
Be back at it early tomorrow. Peace out.
You had made the landing without the LiDAR data. And what was the last payload